My name is A41吴文傑. I am a freshman in the Department of International Business. My student ID is 1143010009. I'm going to talk about Topic 1 Trumponomics. It's Topic 1 Trumponomics, and this is the contents. I will start with the background of Trumponomics, and next is tariff, reciprocal tariff between Taiwan and the U.S., and next is the quota versus tariff, and next is graphical analysis, and welfare effects is the final. Background of Trumponomics. It's a policy of America first. It emphasizes protectionism and reciprocal tariff on major trading partners, include Taiwan. So, what's tariff? Tariff is a tax imposed by the government on imported goods. It makes foreign products more expensive to protect domestic industry and generate government revenue. It can also serve as tools in trade negotiation. And reciprocal tariff between United States and Taiwan. When the United States imposes a tariff on specific Taiwanese goods, Taiwan would respond by imposing an equivalent or comparable tariff on U.S. goods. Under Trumponomics, this strategy is used to pressure trading partners and achieve more favorable trade terms. It emphasizes equality and reciprocity. The example between Taiwan and the U.S. is a provisional 20% reciprocal tariff on Taiwanese goods, which is effective in August 2025. It was initially proposed at 32%, but after negotiation, it is 20% now. And there are some exemptions, such as semiconductors and data processors and so on. Both United States and Taiwan are still negotiating for the final, finding more favorable rate and trading mode for both sides. And next, what's quotas? Similar to tariff, quota is a trade restriction to protect domestic industries, but it's not the same. Quota sets a physical limit on the quantity of a good that can be imported into a country during a specific period. It directly caps the volume of imports, regardless of price, so it's a predictable limit of import quantity. It can protect domestic industries, but in the meanwhile, it may make domestic price increase and some potential inefficiencies in the market. But when the government wants to achieve absolute certainty of import volume to protect sensitive domestic industries or manage scarce resources, they would prefer quotas instead of tariff. And let's see the difference between tariff and quotas. First, the nature of restriction. Tariff is kind of price mechanism, and the quota is kind of quantity mechanism. And the tariff would generate government revenue, but the quota wouldn't. And tariff affects import quantity indirectly because quantity would adjust with price, and the quota affects quantity directly because government limits quantity of import goods. Both tariff and quota would cause deadweight loss, but the market would be more efficient and elastic when a tariff is adapted. And the price effects. The new price after tariff be imposed. would be previous price plus the size of tax or tariff. But the quota affect the price by market mechanism, also law of supply and demand. And let's move on to the graph. This is the graph from the United States perspective. We can see when it without trade, the domestic price would be P0 and the import quantity would be 0. And domestic quantity would be Q0. When there is international trade without tariff, the price would be PW, and the import quantity would be Q1 minus Q4. And when it with a tariff, the price would be PW plus T, plus the size of tax or tariff. And the quantity would be Q2 minus Q3. Okay. And this is the graph of Taiwan export market. We can see when it's international trade without tariff, the export price would be PW, and the export quantity would be Q1 minus Q2. When it with a tariff, the price would be PW plus tariff, and the export quantity would be Q3 minus Q2. And the equilibrium price without trade would be P0. Equilibrium quantity without trade would be Q0. And when there is international trade, regardless tariff, the equilibrium price is PW, and equilibrium quantity would be Q2. So the tariff wouldn't affect the equilibrium price and equilibrium quantity. But we can see a supply curve would shift to the left because when a tariff was imposed on Taiwanese goods, they would lose competitiveness in United States market. So Taiwanese producers would reduce the supply, and also making a decrease in export. And final, we are going to talk about welfare effects on Taiwan. Start without international trade. The consumer surplus would be ABD. We can see the above graph. A, B, C, D, E, F, G, H. The blue part is H. Okay, so producer surplus would be E and F, and the government earn nothing, so 0. Total surplus would be A, B, D, E, F. When it is international trade without tariff, the consumer surplus would be A, so minus B and D. Producer surplus would be B, C, D, E, F, G, so plus B, C, D, G. And the government also earn nothing, so 0. The total surplus would be A, B, C, D, E, F, G, so plus G. And when a tariff was imposed, the consumer surplus also A, but the producer surplus would be B, C, D, E, H, so minus F, G, plus H, and the government still earn nothing. The total surplus would be A, B, C, D, E, H, so the same as the producer surplus minus FG plus H. So we can see the deadweight loss would be FG minus H. And the welfare effects on United States, we can see the graph. A, B, C, D, E, F, G, H. The consumer surplus would be A when it without international trade, and the producer surplus would be BDH. And the government earned nothing, so 0. Total surplus would be ABDH. And next, international trade without tariff. The consumer surplus increased by B, C, D, E, F, G. And the producer surplus minus B and D, only H. The government still earned nothing. The total surplus would be A, B, C, D, E, F, G, H. So plus C, E, F, G. Okay, so next is international trade with tariff. So the consumer surplus would be ABC, only ABC. So minus DEFG. But the producer surplus would increase by D, so it's D plus H. And when there's a tariff, the government would earn a tariff revenue about F. So the total surplus would be A, B, C, D, F, H minus G and E. So we can know that the deadweight loss would be E and G. Here, the purple part, two purple parts, triangle. And the tariff revenue would be the size of tariff times quantity, import quantity. So it's Q2 minus Q3. So tariff revenue is part F. And part F is bigger than E and G. So there's a profit about imposing a tariff. And this is the end. Thank you for listening.
My name is the first year student of College of Communication, student ID 114455157. The topic I will present is topic number 2 about TSMC. Hi everyone. The topic I will present is TSMC's dominance in the advanced trade market, pricing, cost, and competition. TSMC currently holds a virtual monopoly, producing over 90% of world's most advanced nodes, such as 3 nanometer and below. Key clients like Apple and Nvidia depend heavily on the technology for AI and HPC. The core characteristic here is the huge capital barrier to entry. For advanced trade, TSMC determines its profit maximizing quantity QN by fulfilling the condition where marginal revenue equals marginal cost. The price PN is set at highest point on demand curve corresponding to QN. And the economic profit is represented by the orange rectangle on this graph. And compared to perfect competition, the monopolies market setting of PN is higher than marginal cost, then results underproduction and a loss of total social welfare. This loss represented by the deadweight loss triangle and is represented by the green triangle on this graph. And consider external factor. Massive AI chip demand surge from firms like Nvidia shift the demand and marginal revenue curve sharply to the right. This demand surge leads directly to an increasing in the both equilibrium price and output for advanced AI chips. TSMC's cost model is dominated by its fixed cost, primarily the capital expense for fabs and the cost of EUV equipment and huge budget for fundamental R&D. This do not vary with many numbers of chips produced, and its variable cost includes wafers, chemicals, and extensive power and water resource required for clean room operation. Crucially, the high FC and continuous economies of scale, where averaging total cost falls significantly with increasing output, strong reinforce the natural monopoly characteristic of manufacturing. The profit visualization and as shown of the graph from number 1, the economic profit is measured as rectangle area, the orange rectangle area, and is determined by the vertical gap between PM and averaging total cost. And TSMC can sustain positive long-run profit in advanced nodes primarily due to the huge barrier to entry the market. More importantly, its technological leadership ensures a higher yield compared to competitors, translating directly into lower effective unit cost. This allows the company to reinvest its monopoly profit into R&D, continually wiping the technological gap. TSMC's decision to build a new fab in USA, Japan, and Germany are without question no wrong decision. This because the construct of fabs represent a huge non-reversible fixed investment that fundamentally alter the company's scale of production and its cost structure for decades. In the long run, all factors of production, including fixed capital, are variable. If competitors like Intel Foundry Service (IFS) or Samsung successfully develop and compare 2 or 3 nanometer technology, the market structure will change from a near monopoly to an oligopoly. This shift means TSMC will face increasing price sensitivity and a more elastic demand curve. Competition will intensify, potentially leading to lower price and reduced profit margin as firms engage in strategic pricing behavior. In summary, TSMC leverages higher barrier to entry and massive scale to maintain monopoly profit. Its long-run expansion decision reflect strategic commission to future capital. The ultimate test will be the transition to the uplogic, where sustaining leadership requires not just technology but also continued cost efficient and autonomous. And this is my presentation. Thank you.
大家好，我是叶博瑶。My name is Brian. Next part is my presentation. Let's go! Hello everyone, my name is Brian. Today, I want to share air pollution. This is topic 3. My example of negative externality is air pollution from vehicle emission in major cities. Air pollution causes many serious problems such as health problems, environmental damage, and all of that is negative externalities. In this case, the producers are car workers, car owners, and the industry that emit pollutant. The victim are the pedestrians and everyone in the society. Negative externality lead to the market failure because the producers only consider their private costs, such as fuel and the production cost. They ignore the externality costs that a society must bear, like health problems and environmental damage. Since these social costs are not reflected in the market price, the market produces more pollution than is socially desirable. In other words, the market fails because it does not account for the full social cost of production, so too much pollution is generated. Graphical. In the graph, we can see two curves, the marginal private cost and the marginal social cost. and this is demand of social. The marginal social cost is higher because it includes the internal cost of pollution. Without government intervention, the market equilibrium occurs where demand intersect. MPC, this equilibrium quantity is higher than the socially optimal quantity, which is the point where demand intersect. MSC. This difference creates a delta loss. A delta loss represents the loss of total welfare because the market produced too much pollution. This one. These extra units of production generate more social cost than social benefit, so they reduce overall efficiency. This means resources are allocated in a way that harms society, which is why their loss reflect a loss of market efficiency. Solve how to. There are two types of solution. First, command and control approach. For example, the government can set emission standards or require pollution control technology. These may directly limit pollution, but it can be costly and inflexible. Second is market-based approach, such as Pigouvian tax. A Pigouvian tax charge producers an amount equal to the external cost of pollution. In the diagram, this takes shift MPC curve up where unit it overlaps with the MSC curve. When MPC move up to MSC, the market reach the social optimal equilibrium. This means producers now face the true social cost of their action, so they reduce their output to the socially desirable level, like this. Next part, real-world policy example. A real-world example is Taiwan air pollution fee system. Taiwan charge industry based on the amount of pollutant they emit. This policy has successfully reduced emission from large factories. However, there are challenges such as the high cost of monitoring and the possibility that the industry pass the extra cost to consumer. Extended thinking. Pollution does not always stay within one country, like China in the February or March. Sometimes it crosses borders and affect neighboring countries, creating international externalities. To address this problem, countries must work together. International tools like carbon market and the global climate agreement can act as Pigouvian mechanism. These policies encourage countries to reduce emissions by internalizing the social cost on global scale. Thank you. That's all.